Allô? Ah oui. Donc, nous commençons. Donc, bonjour également de mon côté à Hyvolution 2023. Donc, on m'avait dit qu'il serait favorable de faire cet exposé en anglais. Donc, je vais passer à l'anglais maintenant. Donc, ladies and gentlemen, it's a big pleasure for me to present to you today on behalf of AEG Power Solutions the optimization of total cost of ownership in power conversion for large-scale green hydrogen production. So my name is Andreas Emmert, and I'm responsible for the global business development management within the renewable energy markets within AEG Power Solutions. So to start, some words about AEG Power Solutions. So at AEG, we are experts in power electronics, and we design and manufacture products, systems, and solutions to ensure the continuous operation of critical processes in demanding applications. And as such, we are active in many different markets, such as power generation, transmission and distribution, non-stop industrial processes, rail infrastructure, and also when it comes to renewable energies, to energy storage systems and solutions, namely battery and thermal energy, to facilitate the integration of renewables in on-grids or off-grids. And last but not least, green hydrogen production, the topic of today's presentation. So AEG is a global company with a global footprint. Together with our 29 service partners worldwide, we are present on all continents in the world. We have manufacturing facilities in Germany and in Spain, and we have a service competence center in France, in Tours. We also have manufacturing capacities in China and in Singapore. So I would like to start to recall the importance of green and low carbon hydrogen for the energy transition. And for this, I would like to cite a paper from 2021 from Hydrogen Council, where the authors state that green and low carbon hydrogen could contribute up to 11% to the required cumulative CO2 emissions reductions necessary by 2050 in order to limit global warming according to the Paris Agreement below 2 degrees. And you can see here on the right-hand side the different sectors that might most profit from this way to decarbonize. First of all, at the bottom, of course, replacing grey hydrogen and existing industry use by green hydrogen. Important also the transportation, in particular heavy and long-haul transportation, and then other applications such as heating with high level of temperatures and new applications such as decarbonization of steel production with green steel. So what does this mean for France? So there are many scenarios around at the moment under discussion, and I would like to cite two of them published by RTE in 2021, where you can see that they expect on the horizon of 2050 to have 50 terawatt hours of electricity to consume for green hydrogen production. And in another reference scenario called Hydrogen Plus might be even 171 terawatt hours of electricity. So if you now make a very, very simple calculation by assuming 100% load factor, you would end up in 2050 to have installed 6 to 20 gigawatt of electrolyser capacity installed to absorb these amounts of electricity. And this, of course, only gives the pure minimum of installed capacity would you need by then. And if you would install now every year the same amount of this capacity, you would have to start right away now in 2023 to install between 200 and 700 megawatt of electrolyser capacity per year. And this is really the strict minimum. So if we can cite another scenario, the one by France Hydrogen, published in December 22, the projects, the 250 projects they have identified so far about green hydrogen production would allow us to produce 1 million tons of hydrogen in 2030, and this with a installed capacity of 6.5 gigawatt. So this would mean that in average we would have to install 1 gigawatt per year up to 2030. So we are facing a huge challenge also for the industry, of course, and the supply chain. And if you want to know more about these different scenarios, I invite you to come to the presentation of the association GIMELEC, which is today at Forum 2 at 5:30 p.m. So continuing with this scenario by France Hydrogène from December 2022, you can see here with the blue bars the number of projects known in the pipeline as of today in France. And you see this by category of project size, okay? And you can see that on the left-hand side, most of the known projects today, so 70% of them, are small projects below 3 megawatt, and they will produce only a small proportion of the green hydrogen by 2030. And only a few, so 24 projects, big, large-scale projects, will account for 80% of the production. So what we can learn about this trend is that we will see in the following years a parallel development of smaller and large-scale projects, and it would be, of course, very favorable to have scalar modular solutions in order to profit from the experience and the production facilities we are building up at the moment for the small projects, to put them at service also for the large-scale projects. Now some words about flexibility. So if I come back to the study of RTE, the main message is that the scenario we are heading at the moment, meaning a little bit of new nuclear, but also a lot of new renewable, intermittent renewable on the grid to be expected in 2050, will require more flexibility on the demand side. And for us, it's clear that green hydrogen plants could contribute to this required flexibility. And this would mean for the developers and operators that they should take into account the importance of part load scenarios and the load dynamics, in particular if they would like to participate also to the primary control reserve market. And so what does this mean now for AEG and our power supply that is specifically designed to power the electrolysers in view of minimizing the total cost of ownership and levelized cost of hydrogen? So one has to know that powering electrolysers already is a very specific business and already comes with quite a lot of requirements from the electrolyser side, so which you can see here on the right-hand side. And on top comes additional requirements due to recent trends, which I have just shown in the slides before, and that come from the grid side on the left-hand side. And so I wanted to give you this taste, the flavor of this multitude of requirements that you are faced with when you want to minimize your total cost of ownership. And just to name a few of them, so on the grid side, we are facing stricter and stricter grid requirements, so high power factors at all load, sometimes going up to 1, a low THDI, and also, as just mentioned, high power dynamics. On the right-hand side, specific requirements coming from the electrolyser. So if you want to have one solution, power solution that fits all electrolysers, you have to provide a wide DC voltage range, if possible, going from 0 up to the maximum end-of-life voltage of the electrolyser. And this prevents you of having a pre-charging unit. Second, you have to provide high currents, and this means also high powers to produce the required amount of hydrogen. You should also provide a low output current ripple, otherwise the efficiency of the stacks go down very often, and also they are subject to faster aging. And last but not least, you need a reverse current protection. So when it comes now to the economics, it's of course clear that with the rising electricity prices, efficiency at all load conditions is key. And as we talk about large-scale installations, you don't want to spend your time by repairing or maintaining the equipment, and that's why it's key to have a robust and reliable equipment. And when I say robust, in particular robust against power line disturbances that are more and more often as the grids are under stress. Scalable modular design I've already mentioned. It has to be compact to reduce the footprint of the plants, and last not least, easiness to install to reduce your time on site, which is normally expensive. So now we at AEG, we are pioneers in for the power supply of green hydrogen production. We do this business since 2009, and we can provide today our DC3 rectifier module, which is particularly designed to fulfill all these before mentioned requirements. And so this module is based on a unique hybrid technology that combines IGBT and thyristor technology for integrated grid compliance and a maximum of efficiency, robustness, and flexibility at all operating conditions. And I would like to give you here a flavor about what is behind this technology that allows us to fulfill all these different criteria. So here you see on the right-hand side a very simplified schematic of our hybrid technology that consists on the AC side of a B6, B12 thyristor rectifier, which is very robust against power line disturbances. And on the right-hand side, you have a full IGBT DC-DC converter that gives you both the flexibility needed to provide the big voltage range for the electrolyser. And on the other hand, here on the DC link, we can put a DC link voltage that allows us to drive this thyristor-based rectifier always at full duty cycle, meaning at its best operational point, which is very favorable for its performance in terms of grid compliance and efficiency. And so here you see again the different benefits you get out of such a design. And I would like just to stress now on the next slide the modular and scalable approach and the easiness install we can provide with our solutions. So our rectifier module is scalable, so you can put up to 8 of these modules in parallel and provide powers of up to 10 megawatt. And we can provide them in different packages according to the power requirement of our customers. So for smaller projects of 1 to 2 megawatt, we normally fit our equipment directly into the container of the electrolyser OEM. For higher powers, we can provide a plug-and-play auto container solution. And for even higher powers, normally the transformers are getting too high to fit into a standard container. And in this case, we provide a plug-and-play skid solution. And of course, we can also integrate our equipment in any other kind of building or plant, in particular also future megawatt and gigawatt factories. So here you can see a view of the transformer rectifier unit when it comes in a container packaging. So on the right-hand side, our DC3 rectifiers, AC distribution, in the middle the transformers, and on the left-hand side the chillers for the water cooling system. And on this slide, a more detailed view about our skid solution, up to 10 megawatt DC voltage, up to 1,500 and 16,000 ampere DC. Transformers, rectifiers, and chiller. And so now, most important part, references. So as I said, we are a pioneer in green hydrogen production, active since 2009. And we have today a proven record of hydrogen capacity in Europe in operation. So not only as studies in the drawers, but really in operation. And we power, among others, all these very known electrolyser OEMs you can see here on the right-hand side. So I would like to start with the Emprise project. It's a project in Austria. So Emprise is a supermarket chain in Austria, and they decided to use surplus energy from surrounding wind farms to produce their own hydrogen to power their bakery and also to fuel their delivery trucks. And here we have a 3.6 megawatt alkaline electrolyser from Sunfire. And in this project we had to face a particularly severe grid and also grid serving requirements. And here you can see our rectifiers installed into a concrete building, 8 DC3s, transformers, and we also made the commissioning. Then very interesting project developed by Hydrogène de France that also have a booth today here. It's actually Centrale Électrique de l'Ouest Guyanais in South America, so France, of course, still. And it's the world's largest baseload power plant. And so they use photovoltaic combined with battery storage, electrolysers, hydrogen storage, and fuel cells to provide this base load even during night when the sun is not shining. And our direct customer in this project is Siemens Energy, which is also the system integrator for the full hydrogen system. So this plant will work with McPhee alkaline electrolysers, installed capacity 16 megawatt. And here we supply 32 DC3s with 8 transformers. And then 3 more references I like to cite, not really because they are very big, but I find them very interesting. Start on the left-hand side. It's an interesting project because it's a pilot project, a research project about the decarbonization of steel production, so producing green steel by using green hydrogen. So here the electrolyzer OEM is Hydrogen Pro, it's alkaline electrolyzer. Then in the middle, some of the many projects we see also developing in France below 3 megawatt are projects developed by municipalities, in particular for transportation applications, meaning fueling public buses or garbage trucks and this kind of equipment. And we have, that's why I've chosen this reference. So this is a reference in Germany, and it will use HTEC systems electrolysers, so they are PEM electrolysers, to produce green hydrogen for public buses and trucks. And then, last but not least, one of our oldest references from 2011, where already at that time the idea was to use surplus energy from wind farms to produce green hydrogen, store it, and re-electrify it to overcome emittancy of renewable energies. So we can see that this, even though it's a very old project, it already dealt extremely important topics for today. So now, let me conclude. AEG, as I said, is pioneer in green hydrogen production since 2009. This allowed us to develop a unique hybrid technology that minimizes green hydrogen production costs at all loads. It has a proven robustness, high efficiency, DC dynamics, and quality. It comes with integrated grid compliance. It offers a wide voltage range and is compatible with all electrolyzer OEMs. It's designed and manufactured in Europe, and we still put a lot of invest in our R&D activities to stay up to date with the current developments and offer you always the best and most efficient solutions. And last but not least, even after installation and commissioning, we don't let you alone, and we are at your side with our worldwide service network. And here, by the way, you can see a screenshot of one of our DC3s. And you can read yourself the current and voltage and power that is produced at this M-Price reference here. And yeah, with this, I would like to invite you all to come to our booth, which is just next here, next to the Forum 3. You can see it here. And discuss with us, ask the questions you want to have answered to our experts. And you can also have a look at the real model of our DC3 rectifier module. Thank you very much.